Hello friends, we are with you with the third video about Python. The next point which is very important and becomes more important as we go forward is the order of operations. In fact, the same thing that we know in the mathematics as the priority of calculations. In fact, if an expression has more than one operator, the evaluation of that expression depends on the order of those operators. Python mathematical operators follow the same mathematical rules. Multiplication, division, exponentiation, and parentheses work in the same order as they do in mathematics. This arrangement had an abbreviation called PEMDAS, where P represents parentheses, E represents exponentiation, M represents multiplication, D indicates division, although the priority of these two is equal. A represents addition and S represents subtraction. The priority of these two items are equal to. It is the same in mathematics, it is the same in Python. Okay. For example, parentheses have the highest priority. As you can see, Python also follows the same priorities. For example, we can calculate the percentage of hours that have passed in this way. Let me see. Let me define the variable percentage. Let me define the variable percentage. Minute multiplication. This and this. Okay, what do you think? In your opinion, if we press enter, what will happen? Let's see. We got error because the name minute is not defined. We have to define this name. Okay, we will back to it here just a few minutes later, but I wanted to show you that the priority of parentheses is higher than, for example, the division or even multiplication here. Let's do something else. For example, let's see that if we want to calculate, for example, these operations. We see this result. Actually, the interpreter at first calculated this part and then multiplied the result in 25 because the priority of the exponentiation operator is higher than the priority of multiplication. We can see some simpler examples to figure out the concept. Consider 5 multiplying 2 exponentiation 3. You can see that the interpreter at first calculated this part at 2 exponentiation 3, the result is 8, and then multiply the result, which was 8, in 5, and the result became 40. You see that. But if we put a parenthesis here, the same expression but with parentheses this time, you can see that the result differs because the priority of parentheses is higher, and also the interpreter checks the expression from the left to right, and if some priorities of some operators in the expression are equal, the interpreter does these calculations from the left to right in order. Now interpreter calculated the phrase inside the parenthesis. 5 multiplied in 2, the result is 10, and then calculates 10 exponentiation 3, which is 1000. Okay. Because the priorities are respected correctly, we get the right result. Of course, we will get back to it soon. So here, let's leave it and try other examples which we did it. You can check other examples yourself. In these examples, you can see the higher priority of multiplication, division, and addition, subtraction. We can check this. For example, 5 subtraction 2 multiplication 6. We get the -7, -7 as a result. Why? Because the interpreter calculated this part at first because of the higher priority of multiplication operator. The calculator, the interpreter, which also is a calculator here, calculated 2 multiplied in 6, which is 12, and then calculate the whole expression, which is 5 subtraction 12, which the result would be -7. As you know, the order of execution in arithmetic expressions that have operators with equal priority is from left to right. But exponentiation and parentheses have higher priority. You can try different examples yourself. Here are some examples for you. It is true that in some cases there is no need for parentheses, but in addition to considering these priorities, sometimes we use parentheses to make the code we write more readable. Some of these operations, such as multiplication and addition, can also be applied to strings, but for example, the subtraction operator cannot be applied to string variables, and if you do this, you will receive an error. Let's check it. Let's define a variable a with the string value of hello with a space. Then define variable b with a string value how are you. How are you? Okay. Let's do addition on these two string variables. You can see the result. Now let's do subtraction. You see the error. Let's do a multiply. For example, a multiply in 3. You can see the result. B multiply in 5. You can see the result. 1 time, 2 time, 3 time, 4 time, 5 time. The phrase, the string 5 times repeats. if you apply multiplication on strings. So you can apply addition and multiplication operations on strings. Another thing you should pay attention to is leaving a comment. You write code today and look at it in 2 months. You may not remember what you had in mind when you wrote this code 2 months ago. Let's see this pre-written programs. Okay. Through commenting, you can add reminders to your program without any interruption, so that you can easily remember the code if you need to refer back. Gradually, the programs you write become larger and more complex, and naturally, they become more difficult to read. In general, formal languages like programming languages are dense languages. It means that there is a lot of information inside them. When you look at a page of code, it can contain a world of information and complex mathematical and programming operations. For this reason, it is a good idea to add descriptions in natural languages to the program when programming to make it easier to understand the program in the future. These additional explanations are called comments, which starts with this sign, with the square sign, with the hashtag sign. You can see this here. You can see this red text on the screen. These comments do not affect your code. For example, consider the expression we wrote here. Percentage is equal to minutes multiplying 100 and divide the result in 60, which calculates the percentage of elapsed time in seconds. So you can add a comment with a square sign and write what this statement does in natural language. For example, we can actually, because here we are in Python shell, we are in ideal shell, we can add description here, but in script mode we can do that, so that you can easily understand this phrase in the future references. You can add comments on the top line of the phrase you want, or in the continuation of the line where you wrote the phrase. There is no difference if we, for example, add a comment top of the line of code or in the continuation of that code. Let's try it. We can add a comment here. A list including odd numbers. You can see that this line of comment do not affect the whole program. You can put this line of commenting here in the top of the code you want to explain about it, or you can insert this, you can add this here in the continuation of your code. And this method does not differ from the previous one, and this does not affect your program either. In fact, it will be ignored by the interpreter from the point where you put the square sign. The important thing about comments is that the reader, yourself or anyone else, can see what each statement and piece of code does when you refer to the code. For example, here when you want to read the code, you want to read the program, you see that it contains the odd numbers. So these extra commentings are not necessary. So you don't need to write an effect that has every statement or piece of code. Rather, it is better to explain why in the comments. Write exactly why you wrote this statement in the code. It is better to write here why did you consider and defined such a list. Another point is that sometimes it is possible to remove part of these comments by choosing the right name for the variables. For example, in the previous statement with the definition of percentage as a variable name, there is no need to write additional comments, or when there is a need for an expression to calculate the speed inside the code, additional commenting can be unnecessary by defining the corresponding variable name as velocity. You can see here that by choosing the right name, for example, odds here for this list, these additional and extra commenting is unnecessary. But the problem is that this naming style for variables complicates the program and makes it harder to read, because each of these variables are used in different long and complex expressions. So there is a trade-off between writing long name and writing comments. Choosing the right method depends on the programmer and the situation. At the moment we are getting acquainted with the forking tools, I would like to add a point about errors. There are three categories of errors that you encounter while programming in Python. You have a syntax error. You have seen this already. For example, don't putting a parenthesis can lead to such errors. Actually, these syntax errors are related to the structure of your program. When you have a syntax error, Python will give you an error and draw a red box where it thinks that the error is, which you have seen it up to now. It cannot accurately determine where the exact location of the fault is. At the beginning of programming, syntax error is very common, and there is no need to worry. With a lot of practice and becoming a professional, these errors will be reduced. Another type is runtime errors. They have given the name runtime for this because these errors do not show themselves until when the process of the execution is already started. Then we know these errors as a series of exceptions that occur. For example, a calculation is in progress. It is done correctly up to a certain point, but there is an error from a certain point onwards. For example, you are reading data from a file. That file is an Excel file. There are 200 lines of data and you are reading this data. But you write in your program to read this data up to line 210. When it gets to line 201 and sees no data, it gives you an error. It means that there is no problem starting the program. There is no syntax error either. This style of errors usually does not happen in simple programs. Another type of errors are semantic errors. It means that the program will run. It will not give you any error, but it doesn't show you what you wanted. The program didn't fail, but you gave it the wrong command. You should see where there is a problem with this command. These types of errors are usually hard to find. This section requires practice. You have to try different modes yourself. Since I have been working with Python for a long time, some things that may be obvious to me. You have to enter different expressions yourself and experience different errors. For example, let me show you something here. Okay. Here, let's try it with each other. When you write n is equal to 128 there would be no error. But if you write it in reverse, it means you write 128 is equal to n, then there would be a syntax error. We want to write a program and include in this program a series of executable instructions in Python. At this stage, if you don't understand some parts, don't worry, you will understand completely when we go a little further. I will explain. I will explain this program completely to you. We write odd numbers up to 59. It is better to write the codes regularly. We define a variable called write this moment. Save and run and see the result. We can save it. Excuse me. Let me at the first comment these parts. I will uncomment them soon because this I have written it for speed up the process. Yes, let's save it. Let's save it here. Okay. Okay. Depending on the execution time, one of the two outputs, odd minute and not an odd minute, is printed. For now, we wrote this program to get an overview. As we go further, we see more and more detailed programs. If you write the program and get an error, check the program word by word more carefully. This program works based on your system time. If the number of minutes in your system is even, the message not an odd minute will be printed in the output, and if the minute of your system time is an odd number, the odd minute message is printed in the output. In fact, IDLE asks Python to execute the code you wrote. Python starts from the top of this file and reads and executes the lines one by one. As soon as you press F5, it will run quickly and display the result. We press the F5, save message. Let's give it a name. I forgot to give it a name actually. And okay, this is, we should uncomment these parts. Yes. We can press F5. You see that the message which is printed is odd minute because the number of minutes at the time of execution of the program was an odd minute. We can try it again. We see now not an odd minute. Okay. Friends who are familiar with C languages, please note that we don't have anything like main here. The process is very quick and easy. The point is that Python is the name of our programming language. Let me show you here. Okay. IDLE is the name of the IDE we use. As we said before, when we install Python, an IDE called the IDLE is also installed. While installing Python, an interpreter is also installed. As we said before, interpreter executes the code. It might be a bit confusing. This interpreter is usually called Python. In various sources and books of Python programming language, the same interpreter is also called Python. It is correct to call it Python interpreter. From here, we try to call our programming language Python and call this technology that executes the program interpreter. IDLE is the same IDE that takes your Python code and executes it through an interpreter. In fact, the main work is done by the interpreter. For those who are familiar with Java, the question may arise, is this interpreter similar to Java Virtual Machine? The answer to this question is both yes and no. Yes, because interpreter runs your code like a Java Virtual Machine, but no, because of the difference in the execution method. How the interpreter run your codes in contrast to how the Java virtual machine run it. Actually, you don't see that your code becomes an executable code in Python, like what happens in Java. Unlike Java Virtual Machine, interpreter does not run .class files. Interpreter executes the code you wrote and you don't see anything from the compilation. It is clear that this compilation process happens somewhere, but interpreter does not show us this process. All you see is your code running and IDLE talking to the interpreter on your behalf. In the following, we will talk more about this interpreter. Now let's go back to this code. These are our basic tips and tools. We will not talk about them further. First, we must know these tools well and then use them well. We want to check this code line by line. For this review, we put ourselves in the place of interpreter and we see how we would execute the code if we were in the place of the interpreter. The first line extracts a functionality that already exists in the standard library for us. Datetime is a module and this line imports the datetime function from it. This Python standard library is a set of modules that allow you to use a pre-written and prepared reusable code. That is, the Python development team has made these and provided them to you. This means that this team has created a large collection called the standard library and you can use its functionalities for different applications. During this tutorial, you will see all kinds of modules and functionalities and their uses. Inside this code, we have used the submodule. In this particular case, we see that the name of one of the datetime submodules is exactly the same as its own name. The first one is module and the second one is submodule. This submodule provides a mechanism for working with time, which we will talk more about in the future. In fact, what you often see in Python is the phrase from module import submodule. Another widely used module in Python is OS. OS, we can say import OS. There is a functionality called the get CWD. We can say from OS import get CWD. That tells us where we are now. Get CWD. Okay. Where get CWD. Okay. In the first stage, when we just use the get CWD submodule, we here in Python shell got the result, but if we did it in the script mode, we could not have any results because this wasn't a showable result. If we were coding in the script mode, we had to define a variable named var and assign the result of get cwd to the variable var, and then by calling the var variable we could see the result. But because we have coded in the Python shell, in the IDLE shell from the beginning, we did not face this problem. These modules are a set of related functions together. If we want to draw the whole concept in one form, we will have something like this. For example, getCW is one of the functions in OS. Besides OS, there are many modules such as sys, datetime, random, JSON, and etc. We have a function that is a part of a module, which comes from the standard library. When we say from OS, it means add OS. When we say getCW, it means import getCW from OS among the functions available in the module. To understand the subject better, you can work a little with the standard library and practice. As we know, Python is cross-platform. That means once you install it on one system, you can run its codes on the rest of the systems on your hardware, regardless of whether you have a Mac, Windows, or any other operating system. Sometimes it is important to know what platform we are working on. For this, we introduce the sys module. Let's go to Python shell. First, we add the required module. There are two ways to do this. Or we use the same expression from module, import submodule, or we can import the module first, and after the module name we use a dot and the name of the submodule. The discussion of parentheses also has a small point. There is a reason that some of these keywords are preceded by parentheses and the others are not. We will explain this in detail in future videos. For example, you can use print sys.version. We can see print sys.version, and we can see the result. To see the version of Python installed on your computer, on your system, the interesting point is that if you add datetime as a module and then use the dot method, wait a moment, the parameters inside this module, which are correct to call them methods, will be displayed for you and you can use them. Let's try it. Import datetime. Now write datetime, insert a dot, wait a minute, and we can see its submodules, its methods. Okay. For example, in this example, you can select date. And then today in the same way. Again, insert a dot, wait a minute, and see its subsections. We can find today, choose them. Now we can press enter. And see the result. Let's see what's the different if we insert parentheses. Okay, we can see the date of today. So there is a point in about these parentheses. Okay. There are different modules with different uses. For example, time, you can check the different examples yourself. We can use, for example, is there any module which is named time? Is there any submodule in it? Yes. Get clock info, for example. Okay, we got an error. It tells to us that it needs an argument. Okay, you can work with them yourself. The general task is to add the module and then add its subsections. Because of this feature that Python has acquired through the standard library, it's said that Python is battery included. It seems to always have a battery in it. This standard library has many modules and it is not possible to review all of them in this training course because it takes a lot of time. You can access Python's documentation by searching at docs.python.org. Here. When this site opens, you will enter the description of the version of Python that you are using in the library references sections. You can get complete, comprehensive, and accurate information about the Python library you are using and its modules. If you are interested in getting more information about each of the modules, you can get detailed information about it by searching the desired module name. You can search here, for example, time, and see the descriptions and explanations here. In future videos, the topic will be more interesting. Stay with us.